This is the explanation and discussion of 14.2 quadratic and linear graphs. And we're just starting off with an example of each. A linear graph we've looked at before, they are a straight line. They can go in that direction. We've also seen if they've got a negative gradient, they can go in that direction. And their general formula was y equals mx plus c. M was the gradient, how steep it is. So when it goes across 1, how much did it go up? And then C was the intercept, where it goes through the y-axis. And this intercept is 0 minus 1. So if we thought about that general equation, y equals mx plus c, I've seen that the intercept was minus 1, and I saw that the gradient went, when it went across 1, it went 1 up 1.5, so that I'm going to write more mathematically beautifully as 3 over 2, which is the same as 1.5. We could be looking at more detail now about one of these quadratic graphs. Quadratic graphs come from when you have a function which has got an x squared in it. So the linear ones came when it was just x. You get these quadratic U-shaped graphs when they've got an x squared in them. And some things about them, they have an intercept, just like the linear ones did. So where did it go through the y-axis? It goes through there, again at 0 minus 1. So that's why we've got a minus 1 in this equation, just the same as a linear graph. It also has a thing called a turning point, which is down here at the bottom of the U shape. Turns because it stops from going down to going up, or going the other way from going down that way to up there, where it turns. And then the other thing which mathematicians love, the roots. The roots are where it enters the ground. You can think of that. So where it goes across the x-axis, so that's going to be where y is equal to 0. And we'll be looking at lots of ways to work out what those points are for when y equals 0. The main thing you're asked to do in this exercise is to draw quadratic graphs and just get used to them. One of the key things to remember is that they are this U shape. Why are they a U shape? Because remember, when I've got x squared, a minus times a minus becomes positive. And this is what gives it its U shape. X squared is always or invariably going to be the bigger number. So here 9 is bigger than that, 4 is bigger than that, 1 is bigger than that. Obviously, if we've got a big number multiplied by x, this term here is going to be bigger than that. But by and large, your x squared term is going to be the most important one, and that's what makes it turn up. So if we look at the equation, x squared plus x minus 1. This is my x squared term, x being multiplied by itself. This is the x term, and this is the minus 1. Again, you could have a 2 there, a 3 there. You'll just get slightly different numbers. It will change where the graph goes. It will change these turning points, roots, and intercepts. But once we've got these 3 values here, we add them all up, and we get an answer, 5. So we've got a point, minus 3, 5. So there's my coordinate, minus 3, 5. I can find that, minus 3 there, 5 up there, that's that point. This one will give me minus 2, 1. So minus 2, 1. This one will give me minus 1, minus 1, minus 1, minus 1. This one will give me 0, minus 1, 0, minus 1, which is my intercept, because I've only got that minus 1 on there, and so on. We'll get all these points going along. Create a beautiful U-shaped graph. So that's what you'll need to do for the questions. There will be some points where you've got to find intercepts, and I'll talk about those when I do the questions for you. But for now, that's the introduction, and I'll be doing the questions some in Caboodle, and then some I will have to write down. Looking at exercise 14.2 S, remember these ones, only do the ones that you aren't sure about. These are just practice questions to get used to the skills, S for skills. But when we get on to the A exercises, you should be doing all of those because that's applying your knowledge to exam style questions. And the more you do those, the better. But just for the S ones, just do the ones that you're not sure about to improve those skills. If that's all of them, then so be it, do all of them. Practice makes perfect. So this one, it says a line of gradient 3 and y-intercept of -5. From that general formula, I get y equals 3x, because 3 is the gradient, and an intercept of -5. So it's just applying that. Write the equation. That's what I've done actually. I've done B first of all and written the equation. Draw the graph. So if you're drawing the graph, you know it's going to go through at -5, and you know when it goes across 1, it will go up 3. So you just need 2 points, and then you can draw it. That's something that we should have said about linear graphs really. You only need 2 points to draw that linear graph because it's a straight line. With quadratic graphs, you need more points because obviously they are not just simple straight lines. Moving on to the next question. Number 2 is just the same, so I'll leave you to practice that one. Number 3, sketch the graph of these 3 functions. So sketch again means you haven't got to work out a whole table of results. You can just use your knowledge to draw them. So we know this is going to go through 0, 0 because there's no intercept. Add it on there, and it's going to go across 1 and up 2. This is going to be parallel because it's the same 2x, but it will go through at -3. I'll leave you to think about the other one. Move myself to the other side of the page so you can see this a bit more clearly. This is a really nice question. I like this one. I've had hours of fun myself. The thing to look out for is they're not in the correct format. We haven't got y equals, so I need to swap these around. I'm going to do this one as an example. So I've got y minus 2x. I'm going to need to take that minus 2x to the other side where it will become plus 2x. So that's now a formula, y equals 2x plus 4. That tells me it goes through at plus 4. There it is, and it's looking the right sort of gradient as well. If we do one that might be a little bit more tricky to spot, because we've got quite a few going through at 2. This is going to go through at 2, because you've got y equals minus x plus 2, and I swap that around. And the other one where it's going to go through at 2 will actually be this one, because I'll need to divide that by 2, and that by 2, and that by 2, so I end up with y equals 2 minus a half x once I've swapped it around. So both this one and this one go through at 2. We said this was a half x and this was x, so this is the steeper one. So the ones that are going through 2, the steeper one is this one here, C. So I'd say that one goes with C, and we had this one here going with D. I'll leave you to puzzle out the rest. So number 5 is just going to be a series of lines where you've got y equals and x equals, because they're straight lines. They're parallel to the x-axis, straight across, parallel to the y-axis, straight up. So we'll have x equals -1 to give me this line, and x equals 3 to give me this line. I'll leave you to puzzle out the rest. Now we're getting on to these quadratic ones. X squared, so that will be -3 times -3 is 9, plus 2, that is going to be 11. -2 times -2 is 4, add 2, that's going to be 6. -1 squared is 1, add 2 is 3. 0 times 0 is nothing, add 2 is 2, 1 squared is 1, add on 2 is going to give me 3. So I add there for my line of symmetry, because I had a 3 either side of it and a 2 there. That might help you to sort of start thinking about how these different numbers affect quadratic graph, which is really what this exercise is about. So as I say here, it's lots of practice of drawing graphs, but when you're drawing these, I actually want you to think about what they look like. And you should hopefully find out that this number on the end, the number without any x's in it, affects where it goes through the y-axis. It is just the intercept, like in linear graphs. The number of x's is what actually shifts the graph, whether you get a U shape here, or a U shape here, or a U shape here, that sort of thing. So you'll start seeing a relationship between the number of x's and where the line of symmetry of the graph is, and also the position of the graph on the axes, on the xy axes. Number 7, because it's got a star by it, is just an extension question for those of you that are interested. I'd love to do it myself. Right, so that is taking you through 14.2, which is a lot of practice of drawing these graphs, and for me that's hours of fun. If you've got your maths books, that squared paper should be accurate enough. You don't need graph paper. Those small squares will be enough. All right, take care, and I'll be back with 14.3. That'll probably now be uploaded on Tuesday. Probably won't get that done today. Take care, everyone. Bye-bye.